Hello everybody, welcome back to another video. Today we'll be discussing corrosion control techniques. So in the previous parts, I had told you I'll discuss about this when time comes. So that's the time here. So corrosion control, there is three types. Okay, protective coating, cathodic protection, and design and selection. Under protective coating, this further divided into organic and inorganic. Under inorganic, it's further divided into metal coating and surface conversion coating. Under the metal coating, it's further divided into anodic, which is galvanization, and cathodic, which is tinning. Under surface conversion coating, it is anodization. So what did I say? Corrosion control, three types. First one is protective coating. And protective coating, organic is basically coating the metal with paints or varnishes or greasing. Okay, that is different. Now inorganic is mainly what we're going to study. Inorganic is two types: metal coating and surface conversion coating. Metal coating and surface conversion coating. In metal coating, two types: galvanization, tinning. In surface conversion coating, it is anodization. Under cathodic protection, there is two types again. First one is sacrificial anode. Next one is impressed voltage. Third one is design and selection. Once again, summary I'll just write. When you write, only you understand. Otherwise, you'll be confused. Corrosion control. First one is protective coating. Correct? Yeah. Protective coating. This is organic, that is paints, varnishes, greasing, all that, and inorganic metal coating and surface conversion coating. In metal coating, you have galvanization and tinning, and the surface conversion coating, you have anodization. The next type is, I forgot, cathodic protection. Yeah, cathodic protection. Under cathodic protection, you have first one. So one is impressed voltage. Other one, I forgot. Sacrificial anode. I know what is going to happen, but I forgot the name. And the next one is design and selection. One thing you have to remember is that here in anodization and impressed voltage. Anodization and impressed voltage. Here we'll be using an electrolytic cell. So till now anode was negative, cathode was positive, right? In these two, anodization and impressed voltage, it will be reversed. Anode will be positive, cathode will be negative. Similarly, in impressed voltage also, anode will be positive, cathode will be negative. That you should remember in impressed voltage and in anodization. Okay. So this was the basic thing which is in here. Corrosion control techniques: protective coating, cathodic protection, design and selection. Protective coating, two types: organic, inorganic. Inorganic further divided into two types: metal coating and surface conversion coating. In metal coating, you have galvanization and tinning. In metal conversion coating, you have anodization. Cathodic protection, again two types: one is sacrificial anode and one is impressed voltage method. And then design and selection. Okay. Now, let us discuss each one of them one by one. Firstly, let's start with the type 1, that is protective coating. This was of two types: organic and inorganic. Organic involves paints, varnishes, greasing, all of that. And inorganic, there is two types: metal coating and surface conversion coating. Under metal coating, you have galvanization, which is anodic coating, and then you have tinning, which is cathodic coating. And surface conversion coating, which is anodization. So let's start with galvanization. So before that, let me tell you briefly what exactly is happening. Okay, because that also is important. So metal coating, we're using by electroplating. What we're doing is we're depositing one metal on another metal. We're depositing, don't use big words, we're depositing one metal on another, on the base metal basically. This is the metal to be protected. Because electroplating, already if the words are used, then you'll be getting confused. Anode is negative or positive, cathode is negative or positive. Don't use such big words. Here we are coating a metal or the deposit layer of another metal on the metal which is to be protected. That much simple. Another metal coating method is hot dipping, which we'll keep it on site. So here it is suitable for small appliances. This method is suitable for small appliances, not maybe for big ships and all. For nuts and bolts, small things, you can use this method. So metal coating total two types is there, anodic and cathodic. Anodic is total with galvanization. So let me tell you in anodic method coating what is happening. We have taken a base metal, iron, and we are coating it with an anode. Now we know what is going to happen. This is going to be a more reactive metal. Anode in the sense, we are going to coat it with zinc in this case. I will do anodic metal coating example is galvanization. Say zinc. We know zinc is more reactive than iron. It's an anode. It's if base metal coated with this in anodic, that is anodic, means this is anodic to the base metal. So anodic metal coating, anodic will undergo oxidation, will undergo corrosion. Iron will remain safe. Fair enough. The next type is cathodic metal coating. Here the example is tinning. Here also the base metal is iron, but here we are coating the metal with tin, which is a cathode. Now one more thing, this I'll come to it later. Okay, this is a cathode. Okay, now the base metal is coated with a less reactive metal compared to the base metal itself. Tin is less reactive than base metal. Basically, this is only the anode here. This is the anode and this is the cathode. Okay, now why are we doing all that and all? Different reasons, because this can be used in food industries, this cannot be used in food industries. There are various reasons for that, but there are two types, anodic metal coating and cathodic metal coating. This you have understood. Now how will you tell which is better? How will you tell which is better? I'll come to that first, then I will go to the step-by-step procedure of all of these. Now say take this is the iron and this is the zinc. This much part you have not coated. This much part you have not coated. This is the zinc. This much part you have not coated. Here this is the cathode. This is the anode. This is case 1. Case 2 is same. This is the iron and this is the tin. Again, this much part you have not coated, or it has missed, or something has happened. This is the iron and this is the tin, but here this is the anode, this is the cathode. Now use the brain. Here this much area of the anode is not coated. So this much area of the cathode is not coated. Less cathode region, majority of the cathode is coated with the zinc. More anode. Here observe this much area of whatever is there of the anode. This much area of the anode is not coated. Less area only is not coated. Majority of it is coated. So less anode, more cathode. In the previous video I told you, in the previous one of the videos I told you, less anode and more cathode region is the favorable condition of corrosion. When did I tell you this? In the topic where I have mentioned the the factors affecting corrosion. There I have told you nature of metal, relative anodic and cathodic size, and product of the nature of the corrosion product. All that I have discussed, right? In that part I have told you, mentioned you this. So this is galvanization, this is tinning. Which is preferable? This one. That's what. Less galvanization, the cathode area, anode. This is anode area, this is cathode. So less anode means more susceptible to coating. Less anode area, more cathode area means more corrosion. Here less cathode area, more anode region, so less susceptible to corrosion. So that's why we prefer this. Now I will individually explain both of these. So first step is, first let's understand galvanization. Galvanization is the coating of zinc on iron, where iron, this is a anodic coating. So this means this is an anode and this is the cathode. So first step I will explain in terms of few tubs. First explain this much, then I will go forward. First, what we're taking is, we're taking a, see this is an iron sheet, okay? Think of this as an iron sheet. First we are dipping it in organic solvent. I'll tell you each step what it is doing. Before we are dipping it in organic solvent. Then we are dipping it in dilute H2SO4. So now organic solvent, why it is used means, it is going to remove all the grease. It is going to remove the grease or whatever paint, all of that is going to remove. To remove grease, paint, all of that on the metal surface, whatever is there on this surface, whatever is there, is going to get removed. Next is going to be dipped in dilute H2SO4 to remove the layers of rust or some scale formation, whatever it is, that's going to get removed here in dilute H2SO4. Then what we are going to do is, we are going to dip it next in ZnCl2 plus NH4Cl. This is ZnCl2 plus NH4Cl. What is this going to do means, it's going to prevent the oxidation of zinc. It's going to prevent oxidation of zinc. We are going to coat it with zinc, right? The zinc should not get oxidized. So before only we are going to, after dipping you cannot do anything. Now before dipping only we are going to make it into ZnCl2 NH4Cl flux. It's a flux, okay? It's going to prevent the oxidation of zinc. First only, prevention better than cure, right? That's why first only we are going to dip it in that to prevent the oxidation of zinc. Then we are going to dry it here. Here dryer is there. We are going to dry the surface, and then we are going to dip it in molten zinc at the temperature 430 to 470 degrees Celsius. Then we are going to make it pass on to the rollers. This is the rollers. So you get your desired sheet outcome here. Okay, that's going to be a sheet. This is going to be galvanized iron. This can be used in tubes or pipes or roofs, nuts, nails, like that places. So once again I'll summarize what is happening in galvanization. You're going to take, firstly you're going to dip the metal in organic solvents, which is going to remove the paints, grease, all of that. Then we're going to dip it in dilute H2SO4, which is going to remove the rust layers or scale layers or salt layers, all of that. Then we're going to dip it in ZnCl2 NH4Cl flux, because this is going to prevent the oxidation of zinc. Then we're going to dip it in molten zinc at 430 to 470 degrees Celsius. Before dipping it in molten zinc, we are going to dry the surface also. Then we're going to dip it in molten zinc at 430 to 470 degrees Celsius. Then we're going to pass it into rollers. Then we get galvanized iron. Okay, that was about galvanization. This we cannot use it in food industry because the zinc is there, it is reactive. So in cool drinks and all, it's going to react. So it's going to affect the pH. So toxins will be released into the food. So galvanized iron is not used for food storage. Okay, now let's understand tinning. Tinning also almost similar process. Very few changes are there. That also let me explain now. So first the same process. First we're going to dip it in organic solvent. Then we're going to dip it in H2SO4. Then we're going to dip it in same ZnCl2 NH4Cl buffer. Then molten tin. Then here the change is there. Palm oil. Then we're going to pass it on to rollers. So first we're going to take the iron. This is what? This is organic solvent. This is what dilute H2SO4. This is what ZnCl2NH4Cl buffer. The function of NH4Cl is different here. I'll talk about that as well. Then we're going to pass it on to molten tin. Then we're going to pass it on to palm oil. Then we're going to pass it on to rollers to remove the excess tin. So firstly, this is going to be organic solvent. What is it going to do? It is going to remove the grease or paint. This is dilute H2SO4. It is going to remove the salt or oxide formation which is on the metal. Then this one is ZnCl2 plus NH4Cl. In the previous one, why did we use ZnCl2 and NH4Cl? To prevent the oxidation of zinc. But here, why are we using ZnCl2 and NH4Cl? This flux, whatever is NH4Cl flux there, it's going to help in adhesion of this tin on the metal. It's going to help the adhesion of tin on the metal. Adheres tin to metal surface or iron basically here. Okay, then this is the metal molten molten tin. The temperature here is 330 degrees Celsius. There it was 430 to 470 degrees Celsius. Here it is 330 degrees Celsius. And then this is palm oil. This is an extra step here, that is palm oil. There were only 4. Here there are 1, 2, 3, 4, 5. This palm oil is going to prevent the oxidation of tin. There the buffer was helping in the preventing of oxidation of zinc. Here the buffer is helping in adherence of the tin on the iron. And then after dipping it in molten tin at 330 degrees Celsius, then we dip it in palm oil to prevent the oxidation of tin. And then it is passed on in rollers. It is then passed on in rollers, and then we get desired tin coated iron. Now this can be used in food industries, tins, jam, pickle industries, because this tin does not react with the food or anything. It can be used safely. It won't react or oxidize like zinc. So once again I'll repeat. Tinning, what did we do? First we dipped it in organic solvent to remove the grease or paint. Then we did dilute H2SO4. Dilute H2SO4. The previous one also was dilute H2SO4, you can see. Then that was done to remove the oxide layers or salt layers. Then we dipped it in ZnCl2 and NH4Cl for tinning to help the tin metal to adhere to the iron metal. Then we dipped it in molten tin, 300 degrees Celsius. Then we dipped it in palm oil to prevent the oxidation of tin. Then we passed on to rollers to get the tinned iron sheets. So this was the process of galvanization and tinning. The other processes, let's see in the next video. I don't make the videos too lengthy also. So in the first protective coating, in that we have completed galvanization and tinning, anodization and the others in the next one. See you in the next one. Bye bye.